Yes? No? Maybe so? If you guys don't, then I'm going to go ahead and go over the general equation of a circle and identify or basically tell you guys what each part describes or means, okay? So basically we have a beautiful information given. So write the equation in standard, write the standard equation of a circle with the center -3, -4, and a radius of 6. Now, our general form or center equation of a circle is as follows. We had our beautiful x value. We subtracted the h parameter. It was then squared. We had our y value and it subtracted our k parameter squared, and it was equal to the radius squared. I hope this rings some bells or somehow you are able to recall the parts. Now, each of the parts that we have here in the equation meant something. So for example, we had h, in this case, was our part of our center, our x value to our center. And we had k, the y value to our beautiful center. And the last part that we had here was our beautiful r, which is our radius. Our radius, again, was the value from the center all the way to the end of our beautiful circle, or basically it fell on the end point. So let's see, our center in this case, it's given to us as -3, -4. So center is -3, -4, which means that my center is at HK. So what is my beautiful H value? -3. My K is -4. So I'm going to go ahead and rewrite my equation with it substituted into our beautiful formula. So we have x minus -3. We close our parentheses. Squared plus y minus, my k in this case, it's -4. Squared equals my beautiful radius squared. My radius in this case is, it's 6. It has to be squared. So let's go ahead and simplify. We have x minus -3. It becomes +3 squared plus y plus 4 squared equals 36. Which one of these equations looks like this one? In this case, it would be C. We have positive, and 36. Woohoo! All right. Now, in your assessment, guys, in your final, I want to see you guys able to identify the parts, at least identify your H and your K, and substitute your values. So I want to see you at least 2 steps there. Okay? Yes, Jude. Jude. Anybody else with me? Okay. Anybody else? Okay. All right. Let me go ahead and clear. Let me save and clear. Did everybody have that? Sorry, guys. No, I still see Elijah. All right, now let's go ahead and see this one, number 2. Number 2, what do you guys notice about our equation? X squared plus y squared plus 2x minus 10y plus 10 equals 0. It's written in standard form, it's expanded. So we're going to go ahead and rewrite the equation so we can identify our parts. We're being asked to identify or find the center and the radius. So those 2 items, very similar to how we did the previous example. So center and radius. Let me go ahead and do the center in green and radius in blue. Okay. All right. I hope you guys remember how to do this one. Yeah? No? Breaking my heart, guys. Okay. So now what I'm going to do is that I'm going to go ahead and rewrite my equation, right? So I have x squared plus y squared plus 2x minus 10y plus 10 equals 0. Now, anytime that I have both x and y variables in your equation, they're being powered or they're being brought up to the power of 2, you're going to have a circle. Now, I want to rewrite them so that I eliminate the constant or its place to the opposite side of your beautiful equation. So it's plus 10. Inverse should be subtract 10. So I'm going to go ahead and subtract 10 on both sides. Now, next, before I rewrite everything again in the second row, I'm going to go ahead and rewrite them with a specific strategy. I want to group all of my X values together and all of my Y values together with the purpose of proceeding with the next step. So this is what I'm going to do. I'm going to look at my X values. Which terms have an X variable? X squared and 2X. And which ones have Y values? Y squared and 10Y. So I'm going to go ahead and group them together. So here's my first one. X squared plus 2X. Now I'm going to write an open space. I hope you guys remember Y. Next, I'm going to go ahead and write my Y variables plus Y squared minus 10Y plus another open space equals negative 10 plus what? 2 open spaces. So my first open space and my second open space. Now we need to make sure that we keep our equation balanced. So whatever we add on our left side, we have to add on our left side and vice versa. Okay. Now, do you guys recall what do we write in that open space? Come on, guys. We're going to go ahead and use our B divided by 2 and square it. So it's my half B squared. We're going to go ahead and complete the, not circle, square. We're going to go ahead and complete it twice, here and here. Now, it is done purposely, guys. So we can go ahead and look at our B for the first group. My first group are my X variables. What's my B for my first group? 2 in this case. So it's going to be 2. I'm going to say B equals 2. So therefore, B, all right, 2 divided by 2 squared. What is 2 divided by 2? 1 squared? 1. So this is going to be 1. And whatever we add to one side, we add to the other. Keep your equation balanced. Okay, my second group, guys, includes my Y variables. So what is my B on my second group of terms? In this case, it would be negative 10. So if B equals negative 10, it would be negative 10 divided by 2 and squared. In this case, it would be 5. Negative 5 squared is 25. So we're going to add 25 on one side and 25 on the opposite side. All right. Now, let's go ahead and rewrite everything out. So the first group, we're going to go ahead and factor that. What method are we going to use? Power Ranger. So factor it. Power Rangers to numbers that add up to 1 and, multiply to 1, add up to 2. 1 and 1. My second group, 2 numbers that multiply to 25 and add up to negative 10. Negative 5 and negative 5. So remember that whenever we're completing the square, we do it purposely so we have the same factor twice. Now, with that done, we're going to go ahead and write the factor only once, x plus 1, with the power of 2. Our next factor should be x, not x, y. Remember that we have our other variable. So it'd be y minus 5 to the power of 2 equals, and let's go ahead and simplify the left side. Negative 10, the right side, sorry. Negative 10 plus 1 plus 25, 16. Now can we identify our parts? What are our parts? Let me go ahead and write the general form right underneath this so you guys can see it. We have x plus h. In this case, it's x minus h, sorry. X minus h squared plus y minus k equals r squared. What is my h? In this case, it's positive 1 here. So therefore, negative h equals positive 1. H has to equal negative 1. In this case, negative k equals negative 5. Therefore, k has to be positive 5. And over here, r squared equals what? 16. So what do I have to do to isolate r? Square root. We're only going to take the positive value, guys, because we're talking about distance. So therefore, r equals 4. So we're looking for hk, negative 1, 5, and our radius of 4. Which one has that solution? In this case, it would be D. And again, I want to see you guys show your steps. Let me iterate that or like repeat that. Show your work. In the final, I'm going to be expecting the work. Okay. Okay. Meanwhile, you guys are. All right. Any questions about circles, guys? No. Okay. All right. So we're going to go ahead and move on now to parabolas. This is the next module that we did, the next section that we had. Now, whenever we had parabolas, we had two types. Do you guys remember what type of parabolas that we had? Horizontal or vertical. So let me go ahead and show you guys what a general form of a horizontal and vertical parabola look like. Okay, so let's go ahead and recall our memory. So here's my beautiful coordinate plane. And let's say that if I had a horizontal, I had my vertex, if it was at the origin, the following items happened. I had a directrix at the value y equals a number, somewhere down here or up there, depending on what or how it was facing. And whatever distance this was, my focus had to be the same distance. So these two beautiful segments had to be exactly the same value. So my focus is now at 0p. Now, the general equation for this, whenever it was at 0, 0, and the vertex is at 0, 0, then we had it at x squared equals 4py. So we had to identify what our p value is so we can go ahead and find out what the equation was. Now, horizontal means that it opens up horizontally. So we had a beautiful parabola. And now we have the other type of example. So the next one, we have our beautiful axis. Again, we had our vertex at 0, 0. Let's see. And let's go ahead and say that this time we have a vertical line. And it equals a number. So x equals a number. And it opened up towards our focus. Now this time, instead of it being 0p, it's going to be at p0. And it opened up vertically. So it opened up towards the vertical side of your axis. So this is vertical. Okay, perfect. Now, let's go ahead and identify the information that's given. So what's given, guys? We have a focus and we have the directrix. What is the directrix being represented by? Y equals -4. Which of the two have its directrix as y equals a number? In this case, my horizontal. So I'm going to go ahead and continue on with this type of example. So it should either be opening up or down, depending on what our focus is. Now, yes, we can go ahead and graph it. So we can go ahead and have a visual of our beautiful graph. So let me go ahead and graph it very quickly. Here's my coordinates. And my director is at y equals -4. So 1, 2, 3, 4. Down here, -4. So here's my directrix. And my focus is at 0, 4. So 1, 2, 3, and 4. Zero. Perfect. This means that at the halfway point, my vertex should be located. So if it's 4 units up, 4 units down, my vertex should be at the origin. Okay. All right. Vertex origin. Okay. Now, do you guys remember where it opens up towards? Does it open towards the focus or does it open towards the directrix? It always opens up towards the focus. So it should be opening up. Okay. So I know that it has to be positive since it's opening up. I know that it's a horizontal parabola, so I'm going to go ahead and use this equation to help me out. So I'm going to use x squared equals 4py. Now, what information do I need to find from my equation? P, so let's go ahead and see. P was our y value of the focus. What's the y value of the focus? 4. So if we have our focus at 0, 4, P equals 4. So let's go ahead and substitute that value. X squared equals 4 times 4 times y. What's 4 times 4? Notice here that we're looking at the distance from the vertex to the focus. Since it's opening up, remember when we had polynomials? That was another way to identify if our coefficient was negative or positive. Notice that our equation is opening up, it's positive. That means that the coefficient that x squared is going to have has to be positive. If it were to be facing down, then our coefficient was what? Negative. So in this case, it has to be positive. So let's go ahead and continue right here. 16y, we have to isolate y. So divide by 16. So therefore, y equals 1 over 16, x to the power of 2. If it were the other way around, bless you, where our directrix was y equals 4 and our focus was 0, negative 4, and it had to be facing down, then it would have been negative. It's positive since it's opening up. Now, if we want to do it mathematically, guys, all we have to do is grab the focus, grab the directrix. What value do we have? The y value. This is y equals negative 4. Let's go ahead and see. Remember that we had our p value. P equal our y value minus the y value of our beautiful directrix divided by 2. So what is 4 minus negative 4? Positive 8 divided by 2? Positive 4. So we have our beautiful p-value as well. So mathematically, we proved it. Again, we were trying to find the midpoint between the focus and the directrix, and we found the distance. Woohoo! All right. So which one's this one? C in this case. This one's C. E. All right. How do you feel about these guys? No? Yeah, maybe so. You want another example? Clear. Okay, does everybody have that? Sorry, guys. Not yet? Okay, I'll let you guys copy this down for a little bit. All right, number 4. This time we're given different parts or pieces of information. We're asked to find or write the equation in standard form of a parabola with the vertex 0, 0. And given the directrix at y equals negative 6. Whenever I am not able to identify or see which of these parabolas am I supposed to use, you can go ahead and also or always draw yourself a picture of it, okay? So let's go ahead and create our beautiful graph. All right, now we're given the vertex at 0, 0. That's my origin, so it should be here. This should be my vertex. Now, parabolas, that's going to be where my beautiful parabola starts. That's going to be one of our lowest points or our highest points. Now, from here, we're given the directrix of y equals -6. So that means that I have a horizontal line at -6. So 1, 2, 3, 4, 5, 6. -6. Okay. Now, if I wanted to draw or create the focus, what do we know about the focus? It should be the same distance away from what? The vertex that it is from the vertex to the directrix. So if it was 6 units this way, we have to go 6 units the opposite way. So I'm going to go ahead and draw 1, 2, 3, 4, 5, 6. So this should be at 6, and this should be my focus. So what is the coordinate for that point? 0, what? 0, 6. All right. Let's go ahead and use the information that we used in the previous example. Now, we said that our focus is at 0p, which means that my p-value has to be 6. Positive or negative? Positive 6. How do we know? Because our beautiful parabola opens up, or it's opening towards our beautiful focus. It's a positive parabola. If it were down, then it would have been a negative parabola, but it's not. It's a positive one. Therefore, which equation am I going to use? X squared equals 4py. All right. So we have our p-value. What am I going to do? Substitute. Okay. We have x squared equals 4 times 6 times 1. X squared equals 24y. We have to isolate our beautiful y. So we divide by 24. So therefore we have y equals 1 over 24 x to the power of 2. So you make sure that even though it's a fraction, our leading coefficient is positive. Very similar to when we had polynomials. Now, just in case, guys, I don't think I gave you guys the equation for the vertical parabola. It was, if it's x squared equals 4py, the other one should be y squared equals 4px. So go ahead and write it down in the previous example so you guys can do it. We have time? Yeah, we have time. Let me go ahead and see. Everybody has it. Okay, let me go ahead and clear. And let's go on to this one. Number 5, solve the system formed by the equations y equals 4x plus 4. And y equals x squared plus 7x plus 6. If necessary, round answers to the nearest hundredth. Okay. All right. Now, let's look at this. Let's go ahead and imagine that we just don't know what the solutions are, right? So we don't have anything given. Now, what we're going into, guys, are our systems of equations. We have a linear and a quadratic equation that are going to intersect, or hopefully intersect at 1 point or 2 points or no points. And we're going to go ahead and see where exactly the solutions or those points are. Now, whenever we have systems of equations, there are 3 ways to solve. One of them was what? Elimination. The second one, substitution. And the last one was by graphing. Thank you, guys. All right. So I'm going to go ahead and show you guys how to do both substitution and elimination. Which one do you guys want to do first? Elimination? Okay. All right. So let's elimination first. So let me go ahead and show you guys how to do elimination. Elimination. It all depends on which one you want to use. Do I have to use either or no? You go ahead and select which one you want to use, okay? So elimination, I have my system. Whenever you're giving your equations, always write your quadratic first, then your linear. So this is going to be y equals x squared plus 7, x plus 6, y equals 4x plus 4. Now, if it's elimination, I have to make sure that I eliminate one of the variables. My method here is to try to eliminate the y's. So let me go ahead and rewrite my beautiful equation. So I have y equals x squared plus 7x plus 6. Y equals, I'm going to rewrite the terms underneath the corresponding terms. So I'm not writing 4x here. I'm going to write it underneath the 7x. So plus 4x and our beautiful 4 underneath the other constant. Okay, now elimination means that I'm going to combine these two equations, but first I have to change one of the y's signs. The reason being is because we have y and y, we have to make one the opposite sign. So if I multiply by -1 on one side, I have to do the same on the other side. So I need to make this into a -4x and 4. If they were negative, for example, -4x, it would have been a positive and vice versa. So they just switch signs. All right, let's go ahead and combine y and -y. What happens here? They go to 0. So that's what we want. Next item, we have x squared. 0. So we have x squared. 7x plus -4x. 3x. 6 plus -4. Beautiful 2. So we have our quadratic equation now. So we have x squared plus 3x plus 2 equals 0. How do we solve that quadratic? Well, Power Ranger? You guys don't want to use a quadratic formula? No? You sure? All right, Power Ranger method. But you guys don't have to do anything. It's just substitute your values. Okay, so what items add or multiply? Multiply 2 and add it to 3. 1 and 2. Yeah, they multiply to 2 and add it to 3. Yes. So my factor should be what? X plus 1 and x plus 2 equals 0. What do I do with the two factors? We make them both equal to 0. So it'd be x plus 1 equals 0 and x plus 2 equals 0. So therefore my solutions are x equals -1 and -2. However, we are not done. Since we have equations, we also need the y value. So what do we do with these two values? We go back and substitute. So I'm going to go ahead and create a little table just so I can go ahead and keep my work organized. I have my x values. I have -1 and -2. I need to know what my y values are. So whenever x equals -1, what is the value of y? Which one do you guys want to use? Equation 1 or 2? 2? Okay, so then no worries. So we have y equals 4 times -1 plus 4. 4 times -1 is settle plus -4. -4 plus 4 is 0. So this is at -1, 0. Y equals 4 times -2 plus 4. So 4 times -2 is -8 plus 4. -4. So this value is -4. So what are my coordinates? -1 and 0, -2 and -4. All right, that was using elimination. Let me go ahead and show you guys how to do it by substitution. Okay, substitution. Now, whenever we do substitution, we're basically going to isolate one of the variables and substitute it directly into this second equation in that directly or that corresponding variable. So in this case, both of my equations are already isolated. into y. So we're gonna go ahead and do y equals y. So therefore, I'm gonna go ahead and substitute one equation into the other. So I have x squared plus 7x plus 6 equals 4x plus 4. They're both equal to y, so therefore I can go and make both of them equal to each other, okay? Now, my idea is to make my right side equal to 0. So what do I have to do here? Subtract 4x and subtract 4 so that they eliminate on the right side, and I now have everything on the left side. So we have x squared plus 3x plus beautiful 2 equals 0, and the same procedure falls here. So the same goes on. The same idea. So we have x plus 1, x plus 2 equals 0. We factor it out. We find out that our solutions are x equals -1 and -2, and therefore my solutions for y are the same as your other method. -1, 0, and -2, -4. Zero, -4. You substitute. So you grab your x value and you use one of these two equations.
Okay.
You select whichever equation you want. So you can use the quadratic equation or the linear equation since they intersect at the same point. Whichever equation you use, you should get the same exact y value. So it doesn't matter which one you pick. They should have both the same point. So at -1, it should be 0 for both. At -2, it should be -4 for both equations. Okay, so I showed you guys how to use both methods, elimination and substitution. Okay. Do you guys want to do one more? No? Do you guys want to take a break? Okay, let's take a break right now. All right, let me go ahead and stop it here then.